हेलो स्टूडेंट्स, जो पिछला लेक्चर है उसमें आपने एम्पलीट्यूड्स फाइंड आउट किए थे और हम डिस्कस कर रहे थे नॉर्मल इंसिडेंस। तो नॉर्मल इंसिडेंस हुआ था इलेक्ट्रोमैग्नेटिक वेव का। ओके, हमारे पास सिचुएशन कुछ इस टाइप की थी। इलेक्ट्रोमैग्नेटिक वेव इधर से आती है और ये आपका फर्स्ट मीडियम है, ये आपका सेकंड मीडियम है। इनकी मैग्नेटिक जो भी प्रॉपर्टीज है एंड इलेक्ट्रिक प्रॉपर्टीज है, those are given by epsilon 1 and mu 1 for the first medium. For the second medium, these are epsilon 2 and mu 2, and the incident wave and reflected wave both are in medium 1, and their amplitudes are amplitude of incident wave is E node I, and amplitude of the reflected wave, that is in terms of the amplitude of incident wave, the amplitude of reflected wave, that is 1 minus beta divided by 1 plus beta into E node I. We have calculated it in the previous lecture. Okay, and in the second medium we have only transmitted wave, so it is E node T. This is the amplitude of transmitted wave. The amplitude of incident wave is E node I, and it is E node R. We have done this. The relation between the amplitude of transmitted wave in terms of amplitude of incident wave, that is given by this relation: E node transmitted equal to twice of 1 plus beta into E node I. So you can see we have calculated the amplitude of reflected wave, this one, and the amplitude of transmitted wave in terms of amplitude of incident wave, both cases. So now we are to find the ratio of intensities that will give you the coefficient of reflection and the coefficient of transmission. Okay, we have to find these. For that we will find the intensities. Okay, so in this case of normal incidence we will find now the intensities. Okay, we have to find these things, and after calculating intensities you can easily find the reflection and transmission coefficients. So firstly we will see what does the meaning of intensity lies here. So intensity, you can see intensity, we call it energy falling per unit area and per unit time. Okay, if I have an electromagnetic wave that is traveling in this direction, and I have a cross section here, and the electromagnetic wave is traveling in this medium with velocity v. Okay, and after time delta t, after time t, the distance traveled by the light is equal to this distance. Okay, and the energy density of electromagnetic wave is UEMW. If I want to find out the energy, I have to multiply this energy density with the volume. To find the volume of this cylinder, which is filled by the electromagnetic wave, in time v up to a distance of velocity into time, we will find the first total energy. The energy will be equal to energy density, which is given by UEMW. This is the energy density into वॉल्यूम. ओके, तो इस सिलेंडर का वॉल्यूम निकालेंगे. मान लेता हूँ मैं एरिया ऑफ क्रॉस सेक्शन है मेरा ए और ये लेंथ है, तो वॉल्यूम हो जाएगा एरिया इनटू लेंथ. तो मेरे पास यहाँ पे आ गया एनर्जी ऑफ इलेक्ट्रोमैग्नेटिक वेव इन दिस स्पेस. ओके, दैट विल बी energy density of electromagnetic wave into the area into the velocity into time, यानी कि length. This is length, this is area, it will become volume and this is the energy density. तो मेरे पास total energy आ गई. तो मैंने energy निकाल ली. अब मुझे चाहिए क्या? Intensity. तो अगर मैं intensity निकालूंगा तो intensity मेरे पास आ जाएगी एनर्जी की जगह ये लिख देंगे, दैट इज एनर्जी डेंसिटी ऑफ इलेक्ट्रोमैग्नेटिक वेव इनटू द एरिया इनटू द डिस्टेंस यानी कि वॉल्यूम डिवाइडेड बाय एरिया पर यूनिट टाइम. सो हियर वी हैव एरिया दैट इज ए इनटू टाइम दैट इज टी. सो हियर यू कैन सी टी and t will cancel, area and area will get cancelled. Okay, so this is how you can find the intensity. Now we have to substitute the value of energy density of electromagnetic wave. So energy density of electromagnetic wave, that is given by 1 by 2 epsilon naught and you have here E square. So I am to write this energy density here to get the intensity. So the relation for intensity will become, let me erase it, intensity हमारी हो जाएगी this is equal to energy density का relation पुट कर दिया जो कि ये है, it is 1 by 2 epsilon naught into E square. Okay, into what? वेलोसिटी. देखिए वेलोसिटी कैंसिल नहीं हुआ, नीचे वेलोसिटी नहीं है, तो वेलोसिटी से हम इस फैक्टर को मल्टीप्लाई कर दें अगर, यानी कि अगर मैं एनर्जी डेंसिटी ऑफ इलेक्ट्रोमैग्नेटिक वेव को वेलोसिटी से मल्टीप्लाई कर देता हूँ तो मेरे पास क्या आ जाती है? इंटेंसिटी. तो अब मेरे पास यहाँ पे 3 वेव हैं. वन इज इंसिडेंट, another is reflected and then one is transmitted. So जो transmitted वाला सिग्नल है ये सेकेंड मीडियम में है, यहाँ पे वेलोसिटी मान लेते हैं v2 है, और जो पहला मीडियम है उसके अंदर वेलोसिटी हमने मान ली v1 है. ठीक है, तो अब आप अगर यहाँ पे इंटेंसिटी ऑफ रिफ्लेक्टेड सिग्नल, इंसिडेंट सिग्नल और ट्रांसमिटेड सिग्नल फाइंड आउट करते हैं तो इस रिलेशन का यूज करेंगे. सबसे पहले हम इंटेंसिटी फाइंड आउट कर लेते हैं. इंटेंसिटी ऑफ इंसिडेंट wave. ओके, दैट विल बी, यहाँ पर लिखेंगे I incident, this will be equal to I will substitute the value that is 1 by 2 epsilon naught, and here I will write amplitude of incident wave, its square. Okay, this is the energy density of the incident signal and the velocity. Incident wave is in the first medium where velocity is v1, so I will put here v1. So this is the intensity. Now I will find the intensity of reflected signal. So here I will write a reflected wave. I will represent it by IREF, I reflected. This will be equal to 1 by 2 epsilon. Okay, I am doing a mistake. We are in the first medium, so here the value of electrical permittivity is epsilon 1, and here I have substituted epsilon node. This is epsilon 1. Okay, and the reflected also is in the same medium, so here I will write epsilon 1, and here I will write E, amplitude of reflected signal, and its square. Now we will multiply this factor with velocity of the reflected signal. This is again in the first medium where velocity is v1. So I will write it v1. Now I will find the of transmitted intensity of transmitted signal wave. So I will write it I transmitted. This will be equal to 1 by 2. In the second medium, electrical permittivity is epsilon 2, and the signal is transmitted. So I will write here I amplitude of transmitted signal, square of it, and then I will multiply with the velocity of signal in the second medium. So I hope everything is clear in your mind. Now I will erase it. I will erase this part to find out the coefficient of reflection and transmission. Okay, so I will discuss these, the value of coefficient of reflection and coefficient of transmission in the next lecture. Okay,